Hi everyone. Today I am going to talk about the heat and the specific heat. The heat, we cannot measure directly the amount of heat, but the heat can be gained or lost by an object. So this heat is abbreviated by this lowercase q. And the amount of heat gained or lost by an object is directly proportional to the temperature change. And when we are adding heat, the temperature increases in that object. If the heat is lost, then the temperature of that object will be decreasing. So, the measuring the amounts of change in temperature will help us to quantitatively analyze the amount of heat transferred during that process. So we get an equation: the heat gained or lost equals to the C multiplied by delta T. What is this C? C is the heat capacity. And what is the delta T? Yes, that is the temperature change happened during this process. Let's define the heat capacity, which is abbreviated by the uppercase C. That is defined as the amount of heat required to raise the temperature of an object by 1 degree of Celsius. That is the amount of heat required to raise the temperature of the object by 1, 1 degree of Celsius. So the heat exchange equals to the heat capacity multiplied by the temperature change. That here is the equation. Q equals C times delta T. So what are the units for the heat capacity? The units for the heat capacity equals to the joules divided by the degrees of Celsius. And let's learn a little bit about this heat capacity. The heat capacity is an extensive property. What does it mean? It depends on two factors. It depends on the sample size or the amount. When we change the amount of the object, the heat capacity will also change. And it depends on the identity of the substance. As an example, if I just look at water and iron, I'll get two different values for the heat capacity. Heat capacity does not does depend on the heat capacity depends on the sample size or the amount of the object and the identity of the substance. Let's do an example. Here is the question. A cup of water is used in an experiment. What is the object? Yes, it is the water. What is the object in this problem? It is the water. And its heat capacity is known to be 720 joules per degrees of Celsius. How much heat will it absorb if the experimental temperature change from 19.2 degrees of Celsius to 23.5 degrees of Celsius? So we want to know how much heat will it absorb during the this process. So what is that? It is the Q. We are looking for the value for Q. Right. So Q equals C. We are given the heat capacity. Heat capacity is C and multiplied by the temperature change. Are we given the temperature change? Yes, we are given the initial temperature and the final temperature of this process. So, when we subtract the initial temperature from the final temperature, we'll be able to get the delta T. Q equals C times delta T. So now we substitute the numbers. The C equals to 720 joules per degrees of Celsius and the temperature change will be 23.5 minus 19.2 and you will get the answer as 3.1 times 10 to the third joules. So the units for the Q or the heat is will be obtained in joules. Now we are moving to a new term which is called the specific heat. It is abbreviated by this S. That is defined as the amount of heat the or energy needed to raise the temperature of a 1 gram of substance by 1 degree of Celsius. In specific heat, here this is the special thing, it is mentioned the amount of the substance. It is 1 gram. So that is why we are calling this unit as specific heat. The specific heat is the amount of a heat energy needed to raise the temperature of 1 gram substance by 1 degree of Celsius. So, the specific heat the oh, equals or the specific heat equals the heat capacity divided by the mass. This is the heat capacity and this is the mass. So specific heat is an intensive property. What does it mean? It doesn't depend on the amount of the substance. And what are the units for this? Yes, the units for the specific heat is joules divided by the grams and the degrees of Celsius. And the specific heat is unique to each substance. Like you have learned about the density. So when we know the density, we can find an identity of an unknown substance. Like that, if we know the specific heat for an unknown substance, we can find the identity of that substance. When a substance has a large specific heat means it releases large amount of heat as it cools. Again, it needs a large amount of energy to raise its temperature by 1 degree of Celsius. Here is a question. Calculate the specific heat of water if the heat capacity of 100 grams of water is 418 joules per degrees of Celsius. So the specific heat equals the heat capacity divided by the mass and we are given the heat capacity as 418 joules per degrees of Celsius and we are given the mass of this amount of water as 100 grams. So we substitute these numbers and we'll find the specific heat for the water as 4.18 joules per grams per degrees of Celsius. So what is the specific heat of water if heat capacity of 100 grams of water is 4.18 joules per degrees of Celsius? Again, we'll use the same equation. We'll divide the heat capacity by the amount that is 1.00 gram. We'll get the same number. So what does that mean? Yes, the specific heat does not depend on the amount of the object. Here are some specific heats are given. As an example, the specific heat for carbon is 0.711. Specific heat of granite for about 0.803. Olive oil, what is the specific heat? 2.0. Look, the water, yes, specific heat is 4.184. So, water has relatively a large specific heat. So, then in order to increase the temperature of water by 1 degree of Celsius, it needs in a 1 gram of water. If we take a 1 gram of water, if we want to increase its temperature by 1 degree of Celsius, we need 4.184 joules. So just look at, just think about a big lake. How much energy or how much heat energy will be required to increase its temperature or cool its temperature, right? So to lower its temperature, yeah, lot of energy will be released or will be absorbed during those processes. Uh, let's see how we can do the calculations using the specific heat. Using the specific heat, we can also calculate the amount of heat exchanged during a thermal process. So that heat exchange equals to the specific heat multiplied by mass multiplied by the temperature change. So if I use the abbreviated symbols, then the Q equals to the S multiplied by M multiplied by the temperature change. The units of the specific heat will be joules divided by the grams multiplied by the degrees of Celsius. So, the substance which have high specific heat resist changes in temperature even when the heat is applied. So, that is the reason the even during the winter time, only the surface only the area the surface of the lakes or the big oceans will be frozen, but still the the aquatic environment or the aquatic animals can survive underneath that the frozen layer of the water. Okay, let's see how we can do an question using the specific heat. Calculate the specific heat of a metal if it takes 235 joules to raise. What is this number? Yes, that is the amount of energy required for this process. So it is the Q to raise the temperature of a 32.91 grams of sample. What is that then? Yes, it is the mass. Sample by 2.53 degrees of Celsius. What's that? Yes, it is the temperature change. So we use that equation Q equals M multiplied by S multiplied by delta T. So now we are looking for the S. So we rearrange this equation to solve for S. So S equals Q divided by M multiplied by delta T. Now you plug the values and you get the answer as 2.82 joules per gram per degrees of Celsius. That's how you will use the specific heat in order to calculate the amount of heat released or absorbed during a thermal process. What is the equation you'll use? Yes, the Q equals M multiplied by S multiplied by delta